So, I've been working as a graduate structural engineer for a little over 6 months now, and in that time I've learned a lot of new things. Some of these things have been brand new to me, and some of these things I can vaguely remember my professors covering in class while at university. Nevertheless, with every intention not to forget this information, I've been documenting each one of these things since I started working, and recently I've been reflecting on the fact that I wish someone had given me this information before I started. So in this video I want to share some of the most important things that I've learned and captured on this list, so that those of you who are just starting out can get ahead of the game and not look as silly as I did by not knowing these things. And with that, let's just get started. Alright, so number one is how to read construction drawings, and basically in order to read them effectively, you need to understand how things are displayed and referenced. Now, the first way things get displayed is through something called a plan view, and a plan view is basically what something would look like if you were looking down on it from above. One of the important things to note here is that a plan view is not limited to only looking down at the very top of a structure, but it can also be taken at different heights throughout the building. For example, there could be a different drawing showing the foundation plan view, the ground floor plan view, and then also a different drawing for each level of the building. Okay, and the second way is through an elevation view, and in this view you're seeing exactly what the structure would look like from the side. This view is pretty straightforward, but it's important not to confuse it with the next way drawings are shown, which is through something called a section. A section view is essentially what something would look like from a particular angle if you could slice straight through it and just see it from that perspective without other things that would usually be in the way. Alright, and the last way things are displayed is through something called a detail, and a detail is used to show more specific information in a particular area. A couple of these areas can be at places like at a concrete joint or at a steel connection, and some of the more specific information that can be shown are things like dimensions, reinforcement bar size, and bolt and weld configuration. Also, a lot of companies tend to have a set of typical details which they reuse on projects, so you will get familiar with these ones over time. Now, because sections or details are usually cut or called out on a plan or elevation view drawing that most of the time take up the entire page, are referencing systems being created so that we can keep track of where a detail or a section comes from within the larger structure. And the way this works is through the information that's given in these little circles, which are always split into two halves. In the top half of the circle, there'll either be a section number or a detail letter, and in the bottom half of the circle there'll be the page number that either the section or the detail has been drawn on. And then when you flip to the page that has the detail or the section on it, all you need to do is read the individual drawing titles, and then you should be able to find what you're looking for. Alright, and number two is workflow organization, and to me this is about having a clear method of keeping track of all the information you need for your projects. From my experience, there's two main places you need to keep track of your information, and that's in your project folders and in your emails. For starters, in my email I found that a great way to manage all the different communication I was receiving about projects and things happening within inside the company was to filter them into individual folders. So for example, I could set up a new folder for each project that I was working on, and could also create a folder specifically allocated for things like events, internal company communication, and training. Now, spending the time to set up this system and the extra couple of seconds it takes to file an email each time you get one might sound like a little bit of an annoying thing to have to do, but I promise in the long run it's going to save you a lot of time because it's going to stop you from losing track of information, and also allows you to refer back to specific information on individual projects you've done without having to go through your inbox folder that otherwise would have had all your emails cramped together. Okay, and next is managing the working files for the projects you've been assigned. Something I didn't realize when I first started working is the importance of being able to tell a story with your calculations. And by tell a story, I mean that your calculations need to explain your thinking, highlight your assumptions, and also outline any of the references that you've used that has led you to your final design. So on your calculation sheet, this can be as simple as adding in an extra column off to the side where you can add in your references, or just writing them in line with the text as you go. Now, it's really good that you've used references, but it isn't very helpful to the reviewer if they don't have access to the files you're referring them to. So it's very important to make sure that anything that's referenced inside your calculations is packaged up nicely within a folder so that it can be included alongside your calculations. Alright, and number three is some of the building elements that I only discovered exist once I started working, and some of these I really don't know how I missed. The first one is a parallel flange channel, or for short, a PFC. A PFC is a type of steel beam, and is similar to a universal beam or a universal column, and has all the usual information available on it, which is published in steel member capacity tables. A couple of common use cases for PFC beams are in steel frame stairs, and also in gantry crane railway beams where they are turned sideways and welded to the top of a universal beam or a welded beam. Okay, and the next two elements are to do with stairs, and they are a stringer and a tread. First, a stringer is a stairwell beam that runs diagonally upwards along either side of the steps. But in this context, steps aren't usually referred to as steps, which was a bit shocking to learn. They're actually referred to as treads. Okay, the next element is a girt, and a girt is basically the same thing as a purlin, but instead of attaching to the roof sheeting and the rafters, it attaches to the wall sheeting and the columns. Girts also act in the same way as purlins, where they provide lateral restraint to the flange they are attached to, and can also have fly braces attached to them so that the other flange can be restrained too. Another element I was exposed to is something called cladding, and cladding is essentially the outermost material on a building like roof sheeting or wall sheeting. In my experience, the word cladding is more commonly referred to when designing steel structures, as elements that are restrained directly to cladding, like purlins or girts, have special considerations you need to make and are referenced in the design codes. Alright, and the last two elements are a plinth and a parapet. And a plinth is basically a concrete block that sits out of the ground that other structural elements get attached to, and a parapet is a low protective wall that runs along the edge of a roof or a balcony. Alright, and number 4 is some of the theoretical concepts that I either didn't learn at university or I just don't remember. And the first one is that reinforced concrete slabs don't have shear reinforcement. And this is kind of a funny one because I don't remember my professors or tutors specifically stating this in class, but I do remember that we would only design reinforcement in the primary or secondary direction, and I just never really made this connection. Okay, and the second one is to do with steel connection design. And what I came to learn here is that just because something is welded together doesn't mean that it's a fixed connection, and just because something is bolted together doesn't mean that it's a pin connection. What I discovered really determines whether a connection is fixed or pinned, or in other words, rigid or flexible, is what part of the beam is involved in the connection. Say for example we have a universal beam that is simply supported and has a uniformly distributed load on it. We know from our mechanics of materials course at uni that the top fibers above the neutral axis will be in compression and the bottom fibers below the neutral axis will be in tension. And if we draw the stress distribution over the cross section, we will see that the maximum compressive stress is at the top and the maximum tensile stress is at the bottom. All of this is to say is that the bending moment is carried by the flanges. So if you want to transfer the bending moment from a beam to a column, you need to connect the beam flanges to the column. There are many different ways to do this, and it can be achieved through using both bolts and welds or a combination of the two. And likewise, a pin connection, which is also known as a shear connection, will only require the web of the beam to be connected to the column, because again, if you remember back to your mechanics of materials courses, the shear stress is greatest in the web of a universal beam. Alright, and the last one is to do with retaining wall design. And basically, I was a bit shocked that this was something that I needed to be able to do, because for some reason I thought that this would fall under a geotechnical engineer's scope. So this meant that I did have to brush up on a bit of theory around water and soil pressure loads so that I could design a retaining wall appropriately. The main takeaway here should be that even if you're wanting to become a structural engineer, you should listen up in your geotechnical engineering and soil mechanic classes as well, because they are relevant pieces of information you need to be able to understand and apply as a structural engineer. Alright, so there you have it. That was some of the most important things I've learned in my first 6 months as a graduate structural engineer. Also, if you're interested in learning about some of the design tasks I do as a graduate structural engineer, then you should check out this video I made here. And if you want to find out what some of the biggest mistakes are that all engineering students make, then you should check out this other video I made here. Okay, that's it guys. Thank you so much for watching and I'll see you in the next video. Bye bye.